Hello, so we have reached chapter 8, which is concerning arrays. So arrays is the most popular data structures in C, but also not just in C, but in all languages. So at the beginning of the course, so if you want to declare a variable, so we have used int x, for example, if you want to declare a variable x. Now suppose that we want to use 100 variables. So one idea is to declare x1, x2, x3 until x 100, and then you will manipulate all the 100 variables. So it will be very difficult and it's not feasible. So what I will do that is, in case that we want to use many variables of the same type, so we will use the notion of array. So in this case we'll use, for example, int x of 100. It means that I will declare an array of 100 elements, and each element is of type integer, and we will access this element using the x variable. So we'll see that in this course. So we have mainly two types of arrays, one-dimensional or multidimensional. So multidimensional we'll cover it later. So in a unidimensional or one-dimensional array, we have the structure that is formed of, for example, if we have n variables, n integers, so we have n simple variables, so we can group them together into one component which is called the array. So this is an example of an array A, which contains n elements or n components. So we say that n is the size of the array, or n is the number of elements in the array. So in connection with math, we say that A is a vector of dimension n. So there's n element. So let's take an example. Here we have 12 days, so 12 integer variables, and we call the array days. So we have 12 elements. So these are the number of days in each month. So we have an array integer of dimension 12. So, and the 12 components are already initialized, so we already have a value. So it's the same like int x equal to 2. So we initialize directly the variable x. Here we directly initialize the 12 components of the array. So, and in order to access each element of the array, so here we have the array called days. So the first element is days of 0. So we use a bracket, and the last one is days of 11. So always we start from 0, and if we have the dimension is equal to 12, so the last element is equal to dimension minus 1. So you should pay attention to this. So in order to declare an array, so we use here a simple type. So it could be integer, float, double, long, short, as the simple types that we know. We have here the array name, so it's an identifier, and it should match the no restriction. So for example, it cannot start by a number, we can start by an underscore and stuff like that. And here we can place the dimension between brackets, and if you can see, the dimension is here is optional. So we'll cover this in a while. So here is some examples of arrays. So first we have an array A of integer, and it contains 25 elements. We have a second, a double B 100. It's an array of 100 double elements. And last we have a char C10, which is an array of 10 characters. So you should know that the array, the name of the array is the address of the first element. So if, for example, we have this array, so we have a short which contains 5 elements, and let's suppose that in the memory the first element, so A, this is the address of the first element. So the elements will be placed in consecutive order, and it all depends on the size of the array. So just to know that the array name is the address of the first element, and you will see we will manipulate this later in the next year first semester. So how we will declare and will store? So if we have an n component in the array, and if each component it needs n bytes, depends on the type of the array. So in total the array will occupy n multiple n bytes. So let's take an example. Suppose here we have an array of long t14, and let's suppose that the long type is equal to 4 bytes. So if we have 15, so we'll multiply 15 by 4, and so in memory we'll need 16 bytes. So how do we initialize the array? So as we have seen, we will use curly braces. So we'll add in between the curly braces the elements and separate it by commas. So for example, here we have int a5, so we have 5 elements, so we have used curly braces, and you have placed 5 elements in between the curly braces. Here we have 4 floats, and here we have 10 integers. So in case that we omit some of these elements, so if we enter less than 10 elements, so the remaining components will be initialized to 0. So let's see later on some examples. And as I have told you, if I don't place the size of the array here, it's not a big problem. So because in C there's something called automatic reservation, so I can either, for example, declare an array integer of 10 elements and I don't initialize the elements. I can also declare 10 elements and initialize some of the elements, or I can declare an element, an array without the size, and initialize the element. So automatically the compiler will reserve, for example, here 4 elements. However, I cannot write something like that. I cannot declare a variable, an array without initializing it, or without telling the size or pointing the size of the array. So this is not acceptable. So one of these is acceptable. However, declaring an array without specifying the size is not acceptable unless we initialize the variable. So here we have 5 elements. So in memory we'll have 5 multiple the size of the integer. Here we have 4 elements of float, so we will have 32 bytes, and here we have 10 elements. So as an example, for example, here we have an array with the size is not initialized. So what we'll do, so the memory, in memory, in C, the compiler will reserve 5 elements of type short since it's all initialized. Here the size is set, so we have 5 elements, and the user just initialized 3 of these. So as you can see, the remaining ones will be initialized to 0. However, here the user has initialized the size of the array, which is equal to 3, and however he entered 5 elements, so of course there will be an error. So this error, it will not pass because he needs 5 elements, however he reserved just 3. So here we have an error, a compilation error. So as I have said, in order to access the components, the element of each array, we will start with index 0 and we will end with the size -1. So if we have an array integer with 5 elements, so the first element is equal to a of 0, then a of 1, till we reach a of 4. So again, we have this array A, which contains 5 elements. So the first element, which is 1200, it's accessed by a of 0, and the last element is accessed by a of 4. So we can access the element as a simple array, and we can use it, for example, here inside a conditional expression, or we can add, increment, multiply, sum, all of these all together. And again, as a remark, the first element is of index 0 and the last element is of index dimension -1. So in order to read and to display the array forcibly, we need a for loop. Why a for loop? Because I know the number of elements in the array. So for example, here I have declared I want to use an array A of 5 elements, so I need to print f the element. So before we need to assign, but let's keep it to the next slide. So forcibly I would use a for loop. So I will start from 0 till not 5 but 4. So look well, there's a less strictly here, not less or equal. So it's I equal to 0 less than the dimension and I plus plus. So this is the loop. So I will start 0, 1, 2, 3, and 4. And for each I will print f a of 0, a of 1, a of 2, a of 3, and a of 4. So this is it, and then we'll go to a new line. So the same we will do while scanning, while reading an element. So while reading an element, also I need to loop 5 times from 0, especially you should pay attention, it's always from 0 to dimension -1, and I need to do a scanf. So the scanf, it's the same as we have seen in before, yeah, while scanning a variable. So we place, for example, if we have int x, so we do scanf %d address of x. So we have always the same address here, and we use the variable a of I. So the first time is address of a of 0, the second time a of 1, address of a of 2, address of a of 3, and last address of a of 4. So it's always the same. Always we should, while manipulating arrays, we should use for loops. So This was for the unidimensional array. So we have to do some exercises. So for this part, I will do the exercises in writing, so I will not solve it on the compiler. However, for the exercises, I'll move to the compiler. So we need to write a program that reads the dimension n of an integer array. So the maximum dimension is 15 components. Then we should fill the array with values entered on the keyboard and display the array. So the program asks us to read the dimension n. So what does it mean to read the dimension n? And they're telling us that the maximum is 15. So at maximum the user can enter 15 components. However, he can enter less. So for that, we'll ask the user to enter the dimension of the array. So the dimension should be a positive number, and it shouldn't be equal to 0, and it should be a negative. So we will need the dimension, and then we need to read the elements, and then we need to display the array. So let's start. So we'll start with include stdio standard input output dot h. Then we have int main, and then we have the array. So array, let's call it t. So the maximum is 50. So I don't know the variable yet, so I cannot use the curly braces example, and I cannot omit the 50 because it will give us an error. So I need n, and it's the effective dimension. So it's the number of the number that the user wants to enter in the t. So of course I would use integer I for the loop. So first let's read n. So forcibly I will do while. So printf enter n, or enter the dimension, and I will do scanf %d address of n. So I will repeat that as long as n is less or equal to 0. As long as n is less or equal to 0, I'll printf and scanf. When n is greater than 0, which means 1, 2, 3, 4, 5, so I will stop and I will continue. So I will move to this empty slide in order to continue. So I need to read the n element. So n could be 5, could be 10, could be 20. And yes, we have forgot that if the user enters 100, it will be problematic because we don't have a place. So here I need to modify it a bit. So let me erase the brackets and see what we will do. So how can we erase here? So eraser. So we need also to not just repeat the entry of n when n is less than 0. So n is here, so n should be between 0 and 50. So if the user enters, not 0, 1, if the user enters less than 1, for example -5, we should reject this option. And if the user enters 51, we should also reject this option. So as long as n is less or equal to 0, and we see if it's and or n is greater than 50, I need to repeat. So I need to be here in between 1 and 50. So the negation of in between 1 and 50 is n less than 0 or n is greater than 50. So if I have this one, so obviously I cannot use n because a number n cannot be at the same time less than 0 and greater than 50. So if we enter a number n which is less or equal than 0, I should repeat. Or if I enter a number greater than 50, again I should repeat the scanning of n. So now n is in between 1 and 50, so I can now read at maximum 50 elements. So let's start. We have a for loop. Always I will start from 0, and here I less than n. So n, it's the user choice. It's between 1 and 50. I plus plus. I will ask the user printf. For example, I will ask him to enter element %d dot. I used a colon here, and for the %d I will use I plus 1. So on the output on the screen we will see enter element 1, enter element 2. We will not see enter element 0 because a normal user, he doesn't understand that an array should start from 0. So just an output, and we'll do a scanf %d address of a of I. So when we reach here, when we reach the end of the for loop, it means that we have read all the n elements of the array. Now we need to print the elements. So again, we have a for loop, so we can use the same counter because I'm initializing it again from 0, I less than n, I plus plus capital I, and I will print f %d a of I, so there's a space here, and at the end I will place, so after printing all the elements, I will go to a new line. So this is it for this part. So it's very easy. So let me repeat quickly. So we have initialized or created an array T. So we cannot initialize it because we are not the ones that we give the elements to this array. So it's the user who will enter the elements. So, and we have a restriction that the user can enter at most 50 elements. So first the user should tell us how many numbers he wants to enter. So this is the dimension, the effective dimension, which is here, is equal to n. So we need to read dimension n, which is in between 1 and 50. So, and then we need to do a for loop to read the elements, and then a second for loop to print the elements. So let's move to the second exercise, which is a continuation of the first. So we need to calculate and display the sum of the element of the array. So we have this array and we need to sum. So I need to sum. Let's take an example. Suppose that we have this array. I have 1, 7, minus 2, minus 7, 2, and 0. So we have 6 elements. So 6 elements. So the indexes are 0, 1, 2, 3, 4, 5. So again, how can I sum all these elements? So since we have multiple elements, so I need to do a loop. So I need to loop. So again, it's the same loop. So I will loop from 0 to 5, and I need to sum these elements. So in order to sum, I need some place to sum all these elements. So it will be sum. So I will not repeat all this. So we will need a variable sum in sum. And of course, at the beginning, sum would be equal to 0. And then I will do a loop for I equal to 0, I less than n, I plus plus, and I will place in sum plus equal a of I. And this is the sum. It's a or t, it's a. So a of sum, and then I will print f just the sum. So it's outside the for loop, and the loop I'm just summing, I'm just adding the elements. So printf sum equal %d backslash n, the value of sum. And this is it for this part. So we can integrate it in the previous exercise. So let's again continue this exercise. So they are asking us to delete all the occurrences of the value 0 in the array T and tab the remaining elements. So let's take an example. Suppose that the array A is the following. So I need to remove the element 0, and I need to tab the element. So at the end, the same array A should become like this: 1, 2, 7, 3, and I don't know what's in there. So we will have here 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, and 7. So we need this array. So how can we do that? So as you can see, so we need also to loop. So it's obvious that whenever we have arrays, we have to loop. So I need to just remove the element 0. However, in the memory, I cannot remove the zeros and ones. I can just put put another variables, or put another value of the variables in this variable. So I cannot erase. There's no erasers. Just I can place another value in the same cell. So this is the idea. So in 1, I should keep 1 because 1 it's different than 0. 2 is different than 0. However, 0 is equal to 0. So in here, I need to place another value. So what should I do? So I need to find a value which is different than 0. So forcibly, the first number which is different than 0, it's equal to 7. So I need to place 7 in place of 0. So I should place it here. So in order to place 7 at 0, so I need to save the placement, the index of the 0, and I need to find, so I need another index for a variable that is not equal to 0. So for that, I will use two variables, two counters. One, it will tell me the position of the 0, and the second counter will tell me the position of a non-zero number in order to place, for example, 7 into 0. So this is it. So I will erase and repeat. So this is the eraser. So what I will do is that I will use two variables. So I will use I and j. Again, I will erase this one. It's nice to erase. So let's start. So we'll use two variables I and j. So I will start. So it's the normal counter. It will start from 0 till n. So this is I. And also I will start j from 0. So we will see if we'll start from 0. So let's start from 0. So here I don't have multiple colors, so I will make it a longer arrow. So j will start also from index 0. So I will move till what I will do that is whenever I see an element that is not equal to whenever not equal to 0, I will place it at the same place. So for example, a of I is different, or it's I will place it again at the same place. So 1, I will place it 1. So 1 is different than 0. I would be incremented and j would be incremented. So 2 is different than 0. I will be incremented and j will be incremented. However, 0 is equal to 0. I will not increment j, I will just increment I. So again, I here, the element pointed by I is equal to 0. Again, I will not increment j, I will increment just I. So now I is equal to 7. So what I will do is I'll increment j and place 7 here. So j will be equal to 2 here. It points to 2. Then I will increment I. So I is equal to 0. I will not do anything with j. And then I would go to 3. And then 3 is different than 0. So I will place 3 here. And then we will have this array which is equal to 1, 2, 7, 3. So again, the idea is to have two counters, I and j. So I would traverse the array as usual from 0 to n. So there's nothing we'll do with that, just a traversal of the array. However, j, in order to increment j, I will just do that whenever j, the element that pointed by j is different than 0. So let's move. So we will use here another counter which is called j. So j is for the testing and the that points towards a cell that is not equal to 0. So we will loop. So j would be start from 0 and I will start from 0, I less than n. So it's the normal traversal, I plus plus. And what I will do that in all cases I will place t of I in t of j. However, whenever if I want to increment j, so if t of j is different than 0, I would increment j. If t of j is equal to 0, I will not increment j and I will keep it as it is. So this is the idea. I will use two counters, I and j. So I, it's the normal counter that looped over all the array, and j just incremented whenever t of j is different than 0. So in all cases, I'm placing t of I in t of j, and so if t of I is equal to 0, I will place in t of j, but however, I will not move the counter j. So in order to print the array, I will not print it from 0 to n, I will print it from 0 to j, not to n, because n, there's some elements at the end, and we will not care about the remaining elements in the array. So let's move to another exercise. So here we have to write a program that is the dimension n of an array. So again, the maximum dimension is equal to 50, and then we need to fill the array with the values entered on the keyboard and display the array. So this is done, so we will not repeat it. Then we need to store the elements of t in the reverse order without using an auxiliary array, and then we need to display the array. So let's take an example. So let's take it here. So we have an array t. Suppose it contains 1, 2, 3, 4, 5. So index 1, 2, 3, 4. And then so the same t would be, so it will be like this: 5, 4, 3, 2, 1. So the one which is here is now here. and the 5 which is here is now at the beginning, and then we have this switching. So how can I reach the 1 and I can reach at the same time 5? So they are telling us again, so you can use two counters, one that starts from the beginning, so I, so it starts from 0 and will increment with I++, and one that will start from the end, which is equal to n minus 1, so from the end, and it will go back, so like minus minus. So if we call it j, so j will start from n minus 1 and will go to minus minus. So at so I will go like this and j will go like this. So when we are at the middle, when they cross, so it means we have ended, we have switched all these. So in order to do that, so we need to use exchange. So in order to exchange, we need an auxiliary variable. So for that, we will use an auxiliary. So we have j for the counter. So it's the counter from the end to the beginning, and we will use an auxiliary variable for the swapping. So I will start from 0, so 4. I would start from 0. J will start from n minus 1, so from the last index. And as long as I is less than j, so they didn't cross, so as long as they didn't cross, I will increment plus plus, comma, and I will decrement j minus minus. And here I will do the exchange, so auxiliary would be equal to a of I equal a of j, and equal auxiliary, and we have done all the swapping, and then we will just print the array as it is. So maybe you can trace the examples, take just a small example and do the tracing and see what happens with I and j and how it operates. So again, we need to write a program that is dimension n, so we have done that. The maximum dimension is 50, so we have done do while, we have filled the array with using scanf and for loop, and then on the keyboard, and we have displayed done. So we have this option. So then copy all strictly positive components into a second t positive array, and all strictly negative components, negative values, into a third t negative, and then display t positive and t negative. So we have a maximum array of t which contains 50 components. So these components could be either positive or negative, or all positive or all negative. So we should imagine the worst, and we need to subdivide the elements in t into two arrays, one called t positive and one called t negative, and then we will display both. So suppose that t contains 0, 1, and minus 1, just 3 elements. So in t positive, we'll have just one element which contains 1, and in t negative, we'll have just a minus 1. So again, the size of t positive and t negative, so at the beginning is always is 50. So because a user can enter all positive integers, so all the integers are positive. So I need to expect the worst. So t positive and t negative at the beginning, they are equal to 50. And then while doing the traversal on t, I would calculate the dimension of t positive and t negative. So for that, so we will use so the array t, and we'll use two additional arrays, t positive, which is the dimension equal to 50, and t negative, the dimension is equal to 50. So as for the dimension of t positive and t negative, so we will have a new dimensions. So those will be calculated by the program, not the user. And we have the n, which is the dimension of the array t. So how I will do that? So I will loop over the array t, and if t of I is positive, I will place it in t positive. If t of I is negative, I will place it in t negative. What does it mean I will place it? So I will use the counter here, which is t positive, and here which is here is n positive, and here n negative. So I will place, so at first n positive and n negative will start from 0, and when I insert an element, so at index n positive or n negative, I will increment the n negative or n positive. So let's write it here. So n positive, the index of the positive array and the negative array would start from 0, and then I will loop over the array t. So I equal to 0, I less than n, I plus plus, and I need to check. So if t of I is less than 0, so if it's negative, what I should do? I should place t of I in t of negative, and I need to increment the t negative. So I would place t negative in n negative, so this is D, which is equal to, let me remove this, to T of I. And then I need to increment negative. So I can place it as a post incrementation in just one instruction. If it's too difficult for you, you can place curly braces here and say and negative plus plus and remove this from here. However, I like the post incrementation here, so because it's useful. So let's erase. It's way better. So this is for if ti is negative. So else it means ti is greater or equal to 0. So I should use another if. If t of I is greater than 0, I would place in t positive of n positive plus plus t of I. So first I'll place t of I in t and positive. For example, at the first is t of 0. I would place t of I in t of 0, and then I will increment the index of the positive. And so here we don't need curly braces, so because you have just one instruction. And then I need to print the array. So how can I print the array? So I will just print here the negative array. For example, I would use I for I equal to 0, I less than and negative, because I know now the number of elements in the negative array, and I will print off %d t negative of I. And you will do the same for the t positive to print the positive element. So this was for the unidimensional array. Now we'll move to the multidimensional or the two-dimensional. So as we have seen, so one dimensional is just a vector. However, in two dimensional we have a matrix. So it's an array of array or a vector of vectors. So and usually when we say we have a two-dimensional array, we have two dimensions. So in our cases, we call it R and C. So R is the number of rows and C is the number of columns. So it's a two-dimensional array is called square if R is equal to C, and in comparing to mathematics, A is a vector of R, vectors of dimension C. So it's a vector of vector, or it's a dimension. It's a matrix of dimension R and C. So again, here we have an example of a student or grades of 20 students. So we have 20 grades. For example, in C, you had a quiz, and this is the 20 grades. So we have one array which contains 20 elements. The indices are from 0 and 19, and we have this grade. Suppose now that we have 20 tests for 20 course. So we will have two-dimensional. So for example, here we have 10 assignments, and we have 20 students. So we should use an array of arrays. So we have a vector of vector. So here we have 10 of 20. We have 10 rows and 20 columns. So in one line, we will have the grades of all the students in one homework. So this is the first homework grades for all the students. And this is the grades of all the students in the last homework. And this is all the grades of one student. So this is the 10 grades of one student. So we can see it like that. So now we'll move on how we'll declare and how we'll read and display. So the declaration is the same as in the unidimensional. However, we will have a new dimension. So here again we will have a bracket and a number. So the number, it says, so the first one is the number of rows and the second one is the number of columns. So for example, in the last example chart D1540, it means you have 15 rows, and in each row there is a 40 character. So again, the two-dimensional in the array, a two-dimensional array, they are stored in the memory as a sequential array. So if you have, for example, here 3 and 2, so we have a matrix of 3 rows and 2 columns. So in the memory, they are placed as arrays and they follow each other. So they are sequential in the memory. And again, for the reserved memory, so it's the number of rows, multiple number of columns, and multiple the size of the type that you are declaring the elements. So if you want to initialize the array, so for example, here we have 3 rows and 10 columns. As we have seen, it's an array so it's three arrays, and each array is of 10 columns. So we have here the first array, so we know how to initialize it. Here we have the second, and we have third. And since we have a vector of 3 vectors, so again we will use a curly braces. So you should pay attention that you will use two, so there's a curly braces for the matrix, and for each vector, for each row, there's a curly braces. So as a convention, we use multiple lines for each row, so one line for each row. So let's here see the initialization and the reservation. So here we have 4 rows and 4 columns, and all the variables are initialized. Here, for example, we have just the first row is initialized. So again, in C, it will initialize all the remaining rows by 0. Here we have 4 rows, and the first element of each row is equal to 1. So this is it, and it will add 0 for the remaining elements. So this one is an error, because we have in the first row we have 5 elements. However, we have just declared that we need just 4 elements. So this is an error. So for example, in C, we can omit the first dimension, but we can never omit the second dimension, because in the memory, if we omit the second dimension, we will not be able to retrieve the elements in order. So for that, you can omit the first one, because we know the number of rows. However, the number of columns should be mentioned. So here, for example, the compiler will know that we have 4 rows. So this is it. And in order to access the elements, again, we'll start from 0 for the row and columns. For the number of rows, we'll reach to r-1, and for the number of columns, we'll reach to c-1. So for that, the first element here would be equal to a00, and the last element is accessed by a r-1 and c-1, where r and c are the number of rows and c is the number of columns. So in order to read and to display the matrix, we need two loops. One loop to loop over the number of rows, and another loop to loop on the each row, so on the column. So we have here 5 and 10. We have two counters, I and j. So I would loop on the first dimension, which is equal to the number of rows, and the second counter will loop over the second dimension, which is the columns. So, and we will display the elements, the value of each component of the matrix. So this is for printing, though the scanf is the same. So we just need to add the address for scanning the element. So this is it for the second dimension. We also have to do some exercises. So we need to write a program that reads the r and c dimension of a two-dimensional array T of type integer. So maximum dimension is 50 rows and 50 columns. So we'll do the same as we have done earlier in one dimensional, and then we will fill the array with values entered on the keyboard and display the array and the sum of all the elements. So we'll do all what we have done earlier in the first dimension. So let's start. We'll have include the standard input output, and we'll start by the int main. So in int main, we'll have a two-dimensional array, so it's called T. So we should initialize the, so give the dimension, so it's 50-50, and we'll have two counters, I and j. So we will use sum later on because we need to do the summation, and this is it for now. So we need to read the dimensions. Oh, we didn't read dimension, so int r and c, row and columns. So we need to do the reading. So I will read r and then I will read c. So I cannot read both at the same time because I need to do while. So if, for example, the user enters a correct number for r and a wrong value for c, so I cannot force him to re-enter r, which is already correct. So for that, we will split the reading of r and the split reading of c. However, they are the same, it's the same code. So let's do while scanf %d address of r. So you should place enter the number of rows, so I'll skip that. So as long as r is less or equal to 0 or r is greater than 50, I need to repeat that. The same for c, scanf, enter the number of columns, I will read c, and I will repeat that as long as c is less or equal than 0 or c is greater than 50. So I have just read r and c, and they are both between 1 and 50. Now I need to read the matrix, which is of dimension r and c. So we have seen that I need to use two loops for I equal to 0, I less than row, strictly less than row, I plus plus, and then I have a second for loop for inside the first one, j equal to 0, j less than c, j plus plus. So printf, and then I will do directly scanf. So if you will use printf, make sure to use curly braces, percentage d, address, so it's called a or t, I forgot, so it's t, so t of I of j. Then I need to print the matrix, so it's the same for r, I less than r, I plus plus. So let me do the scanf. I will do the printf here. So for here I will use for j equal to 0, j less than c, j plus plus. So I will printf percentage d, a of I j. So this is the I is for each row. I will print all the elements. So here after printing one just row, I will print f backslash n. So for that I will have each row on one line, and then I will move to the second line. So for the scanf here, I would use curly braces, and I will place here printf enter element. So I will place percentage d percentage d equal, so the user will enter something here, and I will place here I plus 1, j plus 1. So on the screen we will say element 1 1, element 1 2, and for example if the user enters for r equal to 5, so we'll see 5 element of 5 j. So it's more like humans, so normal humans, so that use mathematics, so they know that a matrix it has, so the numbers of columns and rows starts from 1, not from 0. However, in our case it all starts from 0. So and then we need to do the summation. So let's do the summation. So again we need 2 for loops. So we could have done it here in the same loop, so we could have done it. However, we will repeat it. So for I equal to 0, I less than the number of rows, I plus plus, and then I have for j equal to 0, j less than c, j plus plus. So I need to initialize sum to 0, and then I will add to sum plus equal, it's called t, I, j. So this is it. So the sum is inside the for loop, the inner for loop, and the inner for loop is inside the outer for loop. So outside of all these, I will print f sum equal percentage d backslash n sum, and at the end return 0, and this is it for this part of the program. If you have any questions, do not hesitate to drop me a message. Of course, I will answer you back. So let's move to another exercise. So we need to write a program that reads the dimensions of two-dimensional array. So already done that. Fill the array with values, already done that, and display the array again. And so we need to display the sum of each row and column using one auxiliary variable for the sum. So if we have this matrix, so we need to display the sum of each row and the sum of each column. So for example, if I want to display the sum of each row, I would say that row 1, the sum would be equal to 6, row 2, 15, the sum of column 1 is equal to 5, column 2 is equal to 7, and column 3 is equal to 9. So we need to display all these values, and we should use just one variable sum. So I will not repeat the reading of the dimension, nor the reading of the matrix and the printing. So I will move directly to the summation first of the rows, and then the summation of the line. So we'll use just one sum variable, so it's the same that we have declared earlier. So we need to loop on the matrix row by row. So this is easy, we know that. So for I equal to 0, I less than row I plus plus. So this is for each row. What I will do for each row, I need to sum all these variables. So for each row I will start from 0. So it's important to place sum equal to 0 inside the for loop, because if I don't place it, if I place it outside the for loop, it means that I will keep the same value of sum. So at the end I will end first with sum equal to 6, and then I will have 15 plus 6, which is equal to 21. So I need to initialize for each row. So before starting by each row, I need to initialize the sum to equal to 0, and then I will loop over the columns. So for j equal to 0, j less than c, j plus plus, and I will do sum plus equal t of ij, and I will printf the sum. So printf sum line %d is equal %d backslash n. Here I will place I plus 1, and I will say sum. So printf is inside the outer for loop. So let's repeat. This for loop is for the number of rows. So it means for each row I will do the following. I will place 0 in sum, and then I will check all the elements in this row. So I will check 1, 2, and 3. So as far as we go with 1, 2, 3, I will add these elements to the sum. So first sum equal to 0. Then when I'm in the loop, sum equal to 1. Then sum would be equal to 3, and then sum would equal to 6. So now j is equal to c. So I have finished the first row. I would printf sum line 1 equal to 6, and then I will move to another iteration for 4. I will move to I equal to 1. So 1, it means here. So I will start sum from 0. I will add 4 to 0, 5 to 4, and 6 to 10. I will end with sum line of 2, sorry, is equal to 15. So this is just for the row. So how can we do for the columns? So here's the trick. So how can we sum the first column, then the second column, and then the third column? So here we'll do the reverse. So I would traverse the matrix, the two-dimensional array, by columns. So I will start from j. So j would start from 0. So 4. I would start. So the number here is the number of columns. Okay, and I will start the sum from 0, and the inner loop is the loop over the rows, and I will add to the sum the element of the matrix, and at the end, so I printf sum colon %d equal %d. So first is equal to j plus 1, and we have here the sum. So this is it for the summation of each row and each column for the matrix. So we have so this is it for the set of exercises. So we need to do that. So write a program that transfers a two-dimensional array M of dimensional R and C into one-dimensional array. So we have a matrix, and we need to transfer it into a one-dimensional array. So how can we do that? So we know that the maximum dimension of the matrix is 10 by 10. So if the user enters a 10 by 10 matrix, so the size of the one-dimensional array is equal to 100. So the maximum dimension of this array V, so it's called V, so it's 100 because it's equal to 10 multiple 10. So this is the maximum. However, the user can enter, it should enter R and C. So R and C we have already done that, but however here the maximum dimension is equal to 10. So we will read that. However, the question here is how can I move these elements to this array? So as you see, here we have the element 0, 0. So we have 0, 1, 2, 0, 1, 2, 3. So we have the element 0, 0. So here we have element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we need, for example, A, which is in A0, 0, it should be in 0. So index 0, 0, it's now 0. Index 0, 1, it's 1. Index 0, 2 is 2. Index 0, 3 is 3. So this is I and this is j. So for now, you can say, okay, it's easy. So in the vector v, so we will use just j. So we'll drop r. So it's correct for the first 4 elements. However, let's move now. Let's see e. So e, it's dimension of, so the indexes is 1, 0, and we should place it in 4, 1, 1, 5, 1, 2, 6, 1, 3, 7. So now you should see what we will do. How can we solve that? So as you can see, we have 4, 5, 6, 7, and what changes here is just the j. So as if we have in the formula, we will have something here plus j. Because at the first we have 0 plus j, second we have not 1, but we have 4 plus j. So from what is 4 here? So what's 4 here? It's the dimension of the column, so it's equal to c. So this is correct for the elements 4, 5, 6, 7, which is the E, F, G, H. So let's continue now. So I is of index 2, 0, and it's placed at 8. So if I follow this rule, it means that I should place the element I in 4, but however it's not correct. However, here we have 8 and 2, 1 at position 9, 2, 2 at index 10, and 2, 3 at index 11. So as you can see here, okay, we still have the plus j, however we don't have just c, we just have number of columns. Look here, we have 2 multiple 4 plus 0, which is equal to 8, 2 multiple 4 plus 1. So c is the number of columns, and as you can see, from where I get 2 multiple, it's the number of row, which is equal to I. So at first I is equal to 0, so I'll just, so 0 multiple 4 is equal to 0 plus j, so I will end up with j. When I is equal to 1, I would say 1 plus 4, so this is here the 1 multiple 4, sorry, plus j, I would reach those stuff. And for this one, 2 multiple 4 plus j is equal to 8. So for each element in the matrix which has an index I and j, I would place it in the vector using this formula. So let's start writing this exercise. So we need include. So I will write it all dot h. So int main. So we will use the matrix M. So it's 10 by 10. This is the maximum dimension. So V would be, the maximum dimension of V is equal to 100. And I need to do two-dimension R and C. And of course I need I and J for the loops on the matrix. So I need to read the R and C, so I will not write it here. So do while, so I will write just for R, do scanf, so we need to use printf, percentage D, address of R, while R is less equal to 0 or R is greater than 10. So the same is for C, so I will not write it. And then I need to read the matrix M, so I will do it for I to 0, I less than R, I plus plus, for J equal to 0, J less than C, J plus plus. So printf element percentage D printf percentage D equal I plus 1, those are capital, J plus 1, scanf percentage D, address M I J. So this is for the reading. So for the printing, so again 4 and printf, so it's easy, already done that. So let's move to the transfer. So I will loop over the matrix, so it's easy. I less than R, I plus plus, for J equal to 0, J less than C, J plus plus. And as you have seen, I have here M I J, and I would place it in V. Let's go back. So it's I multiple C plus J, I multiple C plus J, and this is it. So let's then print the vector V. So for I equal to 0, so what's the maximum dimension? So we know the maximum dimension is R multiple C, I plus plus, and it's just one loop because it's just one array, one vector, percentage D, V of I, and return 0 at the end. And this is it for this exercise. So this is it for the course, also for this lecture. So as for the exercises, so we will do the same for all the exercises. So we'll follow this scheme. So we'll declare the variables, we'll read the dimension, we'll read the data, we'll do the treatment, and then we'll display the result. So we will cover the product of two vectors, the calculation of polynomial of degree, and we will calculate the maximum and minimum value of an array, the insertion of a value into a sorted array. We should find a value in an array, so it's a searching. We will do a sequential search and a binary search. We will merge two sorted arrays and we'll find the maximum using the selection, sort, and the we'll do a sorting. So we'll sort the elements using the maximum selection and the propagation, or it's called bubble sort. So this is for the dimensional arrays. For the two-dimensional arrays, we will zero the main diagonal. We will create a unit matrix. We will work on transposition of a matrix, the multiplication by a real number, addition and multiplication of two matrices, and we'll end with some difficult exercises like Pascal's triangle and the searching for saddle points. So in the booklet, so it's from, we will not cover exercises 8.9 till 8.15. So it's an easy exercise. So you can do it by yourself. So you'll find the solution on the website. However, I will not do videos solving these exercises. Again, exercise 8.24, I will not do a recording for that. So, and this is it for this part. So if you have any questions, do not hesitate to drop me a message, and do not forget to subscribe to my channel and to hit the bell icon to receive all the notifications. And again, thanks for watching.